Now we're going to hear a different kind of thoroughgoing application of GIS technology with commercial and environmental implications. We're going to hear from Jack Levis, who some of you may know from past user conferences where he's been a very popular speaker. He's the senior director of process management for UPS, and he's been with that very powerful and consequential logistics company for a very long time, about as long as I have been with the Atlantic. He also has a flair for the dramatic, as I hope you'll see in a few minutes with his presentation. And if you look through his bio, you will see too. For example, if you look through his online bio, you'll find that before he joined UPS, he had this entry. In the early 1970s, he spent 2 years as a night manager for Motorama in Southern California. And his explanation for this entry was, I had to put in something here for a past position. This was a car museum on Hollywood Boulevard. I drove the Batmobile and Munstermobile here and partied with Kiss one evening. I guess that counts for something. Yes, it does. I think we see somebody who is fated to be in charge of the way that nations deliver their goods and are connected around the world. You all know, those of you who have studied topology, which I'll assume for a GIS conference is most people, you know that the hardest problems to solve, the ones that are surprisingly complex, are those involving routing. What's the most effective way to connect 50 points? UPS is connecting billions of points around the world every day, probably hundreds of millions, at least billions, and the ways in which they have done that, the ways in which they've used this technology to figure out answers, and the consequences in energy, in time, in profitability, in efficiency, in other businesses they've allowed to develop are quite impressive. So to hear more about what UPS has done with the science of where, I give you Jack Levis.
Thank you. Well, thank you, Jim. I think everybody knows that UPS gets kind of crazy at Christmas time, and I've seen 41 Christmases. I'd like to share with you what I've been working on for about the last 20 years, so I'm going to have to go very quickly. And my goal isn't really to share with you UPS, but I'm hoping you can get some insight from what we've done and improve what you're doing for your own organization. As I said, I've got to go very quickly, and I'm going to start my timer now. I might end up a minute or two over. Let's start with some basic facts. And here's the key of things you need to think about. Look at little things. Little things matter. If we can reduce just 1 mile per driver per day, times 55,000 drivers a day, 252 days a year, that's worth about $50 million at the end of the year, just 1 mile. Seconds add up to minutes, and minutes adds up to millions. 1 minute of driver time is worth about $15 million at the end of the year. And what if we can just shut off vehicles appropriately? 1 minute of idle time is worth over $500,000 in fuel alone. You don't need to make huge changes to make a large impact. Look at little things, look at pennies, and the dollars will take care of themselves. This is a bad word. I hate this word. And it's not operations research, it's not operating revenue. This is OR. Do you want improved service or reduced cost? Yes. Do you want sustainability or improved profits? Yes. OR needs to turn into and we've figured out how to turn OR into and by using operations technology, data, and analytics. So let's talk about analytics. Everybody's using the word, but I think we need to put a little bit of framework around it so we can discuss it. My favorite definition of analytics is from the Institute for Operations Research and Management Science. They're called INFORMS. It's an association of people that do this type of work. The scientific process of transforming data into insight to make better decisions. So the key is data turns into understanding, which turns into action and better decisions. So the key is the better decision. If you have data that doesn't turn into insight, that's entertainment. If you have insight that doesn't turn into a better decision, that's trivia. Focus on the decision and the rest will come with it. Think about the decision you need to make. That's analytics. Now, I guess maybe I'm a little grumpy today. This is a pet peeve of mine. We're all chasing things. I hear the buzzwords. IoT, deep learning, machine learning, artificial intelligence. There's all these buzzwords there. But you have to think of that like the dog chasing the car. What are you going to do when you catch it? What's the decision you're going to make? The key is the decision. Once you know the decision, the tools will become apparent. These things are hows, they're not what. Focus on the what, and the how will become apparent. So let's define analytics, and this is my favorite definition of analytics. This is from IBM, and it talks about analytics in a few different forms. Let's start on the lower left. Descriptive analytics, what's already happened or what's happening now. Above it, diagnostic, why did that happen? Then predictive, if I stay on this path, where will I be tomorrow? And prescriptive, what should I do? So analytics starts with, where am I? Why am I here? Where am I headed? Where should I be headed? Now, the key to this chart is as you move through this continuum of analytics, your data needs are going to grow. The skill set needed by your people are going to grow. That's why we hire mathematicians and PhDs. But much more importantly, as you move through this continuum, you're starting to look to tomorrow instead of yesterday, and therefore your business benefits grow significantly. This is exactly UPS's experience. So this means that as you're thinking about analytics, don't let your vision end at describing. Don't even let it end at predicting. If you do, you're leaving something on the table. Your vision has to move into prediction and prescription. So if you believe what I just said, here's some info from Gartner. In the areas of analytics where there's the most to gain, predictive and prescription, that's where the fewest companies are doing the work. Only about 16% are prescribing. 3% prescribing, about 16% predicting. And I want to prove to you through this presentation that this chart is right. You need to move past description into prediction and prescription, past description, in order to get the gains. We've been doing descriptive analytics so long, I'm not even going to go over that with you. I want to start with what we did in the predictive side. As I said, focus on decisions. So we started with the decision this person makes. We call this person a preloader. They load the vehicle for the driver. It's this person's job to say for every package, which vehicle does it go into, where in the vehicle does it go. We do that so when a driver goes to make a delivery, their next delivery is at their fingertips. So think about if this person doesn't do the job right. A driver's going to spend time looking for a package. Maybe they're going to drive around the block. Maybe they have to go revisit an area. Remember the value of 1 mile and 1 minute. This person's very important. But this person in the year 2000 had to have a tremendous amount of information in their head in order to do their job. So we attacked the decisions that this person makes. And we looked at all the data they used to make it, and we built a data model. And I didn't say database, I said data model. It's a predictive model that describes UPS. Where is every package? Where is it going? Where does it need to go? Why does it need to go there? And this way we can simulate tomorrow, we can flip a bit and change the future. That was our goal. That led to the ability, with the data model built, to start building planning tools that are forward-looking. So we are today planning what's going to happen the next few days. We can plan a month from now if we wanted to. But we'll take data that we have and we'll predict where deliveries are going to occur. We can see it textually on the left or geographically on the right. The little blue squares are where we think deliveries are going to occur a few days from now. Before we've even picked up packages, we're predicting where they're going to go. Now, our planning tools will take over, and they'll look for routes with too much work, too little work, or inefficient work. And you can see this one route is red. It's got too much work. So the planner needs to make an adjustment. Again, textually or geographically, they can pick some territory, and this planner grabbed 9 stops. And if you count the little squares, there's 9 squares there. But the little circles are where deliveries might occur, because a package could still come in. These are probabilities. The planner is going to move all that work from one driver to another, and this is how we're working in our virtual world. In essence, we built a virtual network. But you need to communicate from the virtual to the physical. So what we did to handle that is just before the preloader grabs the package, we print a little label. This label tells the preloader where this package goes. In this case, Route 120, position 1118. Our virtual and physical world are now tied together, and we can move a single package from one driver to another if we wanted to. We will update this all the way through until the driver leaves the building. and then we think we have the right routes on the road. We wanted to give drivers information to make better decisions. So in their handheld computer, we call it a dyad, they can see everything they need to do. They don't need to look in the back of the car, they don't need to touch cardboard. They do their planning right in their handheld computer themselves. They can see the addresses to deliver, they could see a general order that they're going to deliver, they could see what time they need to be there, they can also see if there's anything special they need to do and where in the vehicle this package should be. The goal is to help them make better decisions to better serve our customers. We made the dyad smarter. If you request a signature, we know that. The dyad's not going to let the driver leave without getting the signature you requested. Then we went ahead and we indexed other information we had with the packages and gave that to the driver. And here's an example. This customer says, park at the dock, deliver to the mailroom. That bottom one is really interesting. That says no indirect, no reroute, no left at. This customer says, if I'm not home, bring the package back tomorrow. Don't give it to a neighbor, don't do anything else, bring it back. Another customer may say, if I'm not home, give it to a neighbor or put it on the back porch. The dyad knows the difference between the two and won't let the driver make the mistake. Now, your drivers are professional, they're the best in the business, they already know this. But at Christmas time when our volume doubles, or when that driver's on vacation, the person covering your address can be just as effective and just as customer-oriented because we've been able to index this data. So what have we seen from predictive analytics? Remember, descriptive we've been doing so long, I can't tell you what we've gotten, it's just been so long. But once we put in the predictive analytics, let me show you the gains we got going back to that IBM chart. We ended up reducing 85 million miles driven a year. Now, do you see that little formula on the bottom? That's from a paper we won an award with the University of Georgia. That says if you take energy and add information to it, you need less energy. We've reduced our carbon footprint by 85,000 metric tons a year. 8 million gallons of fuel aren't being purchased. Training that preloader reduced 95% of the time, and our drivers are making 8 billion fewer entries a year. That means that they're more productive and you're getting more accurate information. But don't forget or and. We also then offered new products to our customers off of this data infrastructure we built. So I want to talk to you about that for a second. And tracking, that's 1990s technology. You want to talk about where something is or was? That's old school. When we touch your package with a device, it's a chance to make a connection. Our devices are connected to the mainframe, and our customers are connected to the mainframe. So we can open up some new offerings for our customers by using this rich data infrastructure. And we have a product called My Choice. And I'm not trying to sell it to you because it's free. And if you don't have it, just go download it. But look at the things you can do with My Choice and compare it to the data infrastructure that we built. You can get a delivery planner. You know what? It's the exact same forecast that I get. You know when your package are coming, just like I do. You can change a delivery. You can say, I don't need a signature, or I do. You can say to a driver, I want it on the back porch. In essence, we built a rich logistics infrastructure for ourselves, and then we let our customers interact with that exact same infrastructure to make your delivery experience better. That's our motto. So let's move past prediction into prescription. And remember the IBM slide said that there's more to gain in prescribing or optimizing than there is in predicting. So let's look at that in a tool we have called Orion. Now, we were fortunate that we already built this data infrastructure. So it's very hard to move into optimizations without the data infrastructure in place. We're lucky that we started that in the mid-90s. And now we're going to build this optimization platform on top of it. Of course, we're going to put in some customized map data. We're going to have advanced algorithms and some new analysis tools. And that's what Orion is, built on this foundation. Mapping, it turns out, is a corporate asset. Honestly, I didn't understand that when we started Orion, but it's a corporate asset. It's important. We can't do things without accurate maps anymore. And let me show you why. You ever use a nav system that didn't get you efficiently to your destination? This is a real example. Look at where the nav system ends. Look at where the delivery point actually is. 1.2 miles difference. We have to account for that time in miles, otherwise the optimizations don't work. So what we did, and this is more than 10 years ago, we said, why don't we gather information on where we are when we interact with a customer's package? Where are we when we scan the package? Where are we when we get a signature? Where are we when we said we left the building? And we found this out. People are not consistent with where they push buttons. And there's GPS drift as well. So we get this dispersion. But we do have mathematicians, and we came up with some proprietary algorithms to turn this dispersion into this. And without human interaction, we're able to define where addresses are in the United States. You can play Where's Waldo, but there's one address on this screen that we haven't figured out yet. I did check this recently, and we do have that address now. So there's nothing on this screen. I'd have to come up with another example. We have about 250 million data points in our database of address locations. 200 million in the US, about 50 million overseas. So we're using that to help us with where things are. That's important. But as it turns out, where things are is only part of the puzzle. You have to know how to get there. So how do you go from where and have a navigation that gets you there? So we had to come up with our own. And let me again show you why that's important. This is Gettysburg, Pennsylvania. You can see Walmart, you can see the Hampton Inn. Between the two is a Wendy's. That road in front of Walmart and the Hampton Inn is the Lincoln Highway. Go ahead and ask your favorite website, how do I go from Walmart to the Hampton Inn? And here's the answer. Let me explain to you what it did. It knows where Walmart is, nice job. We got 3 little dots that says, I don't know how to get to the Lincoln Highway, you figure it out. Now, it drives you down the Lincoln Highway in front of the Hampton Inn, and it says, I know I can't stop there because it's a divided highway. Keeps going down the Lincoln Highway, finds a place to turn around, turns around, drops you off right in front of the Hampton Inn. Okay, not only is that inefficient, but take a look. This is what it looks like in front of that Hampton Inn. You can't get there from here. The Hampton Inn is addressed on the Lincoln Highway, but you can't get there. So for you and your personal vehicle, that's a frustration. For a UPS driver, imagine giving a UPS driver this answer. An inefficient route and parking in the wrong spot, they did laugh us out of the door out of the room when we tried to use this off-the-shelf data. So we needed Esri. We partnered with Esri, and we had to come up with our own proprietary maps. This is a UPS map. Remember the green squares I showed you before? That's where customers are. Take a look at Walmart, that's 1270. We deliver to the dock in the back, so our map directs us to the back. Do you see 1220? That's the Vision Center. We deliver the Vision Center through the front door. And then look across the street, that's a strip mall. Every individual customer has its own little location. By the way, if you ever want to go from Walmart to the Hampton Inn, here's how to do it. This map is now accurate enough to allow us to go ahead and put optimizations on top. When we make an edit to the map, we had a requirement that was pretty hard for Jack to meet, but he did. If we make an edit to the map, if we move a point, I need that put into production, optimized, and in the driver's handheld computer, 30 seconds. That's the requirement. Because it's a fluid world. I have to make a change, and I have to see it implemented immediately. Now, the driver doesn't know what they're using. If you look on the right, they see their old list, which is in a general order of delivery. We're not going to put an optimization on top of it. That optimization from their perspective is just sorting a list from a general order to a specific order to make the commitments for their individual customers, for that individual day, for the individual needs. And if you take a look, it just sorts the list. It shows them which to do first, second, and third. So that's Orion. Simple idea. I would argue not innovative because you have maps already, we all have nav systems, and computers are powerful. But this is Tom Davenport. He wrote the first book on analytics, Competing on Analytics. His 10-year anniversary of the book is coming up. He's writing the update to it. It's coming out this year. Tom said Orion is the world's largest operations research project. So why? What makes this so tough and innovative? And let me put it in perspective. The Earth is known to be about 4.5 billion years old. This is 4.5 billion years worth of seconds. Average UPS driver delivers 120 stops. Let me show you how many ways there are to deliver 120 stops. It'll stop eventually, but... So, no, I guess another row. So I don't put this there so that I can get some congratulations for our mathematicians. I don't put it there because we were able to implement a traveling salesman problem. That's not why it's there. This is there because this is where the idea from Orion came from. Do you understand the complexity? A driver delivering this route for 30 years doesn't understand the complexities they're under. Even think your chores on a weekend. You don't understand the complexities, so you simplify it in your mind. Can a human actually get through this complexity on their own and come up with the best way to serve their customers, to deliver a route, or even you, what you do on a Saturday? So I'm going to prove it to you, and there's going to be a test. So we came up with something we call the Orion test, and we did it because we needed to convey the complexity of what we were doing. This is a route in Gettysburg, Pennsylvania. You see the little UPS shield up there? That's where the route starts. That's the delivery building. This route is run by Tim On. He delivers 140 stops a day. He's been doing this route for well over 20 years. Look at this. How would you deliver Tim's route? And you'll notice that one decision you make impacts the next, impacts the next, impacts the next. Look at that complexity, and Tim's been running this route for well over 20 years. All right, here's the test. Of all the ways Tim can run his route, here are two. Which one has fewer miles? Don't overthink it. Just decide which one. All right, how many say the one on the left? How many say the one on the right? 50-50. It's always 50-50. I've done this tens of thousands of people. I did it at the US Chamber of Commerce. They had voting machines. It was 45-55. One time, a high school class, 100% of the people picked the same one, and it was the one with fewest miles. The only time that's ever happened, but 50-50 again on which one has fewest miles. 10 miles difference. What's the value of a mile? $50 million. If every driver did the one on the left versus the one on the right, $500 million, and you couldn't even see it. So descriptive analytics, you can't see that there's $500 million to gain. I predict tomorrow, you still don't know it. It wasn't until we optimized that we could find that money sitting on the floor. Don't let your vision end at prediction. There's something sitting there that you can't see. And by the way, the worst part is, he missed service on almost every package. 15% of his customers did not get their deliveries. What if he tried to do that? How bad would it have been? That's why we need these kind of tools, these kind of understandings, so that we can move from or to and. What did we see? Remember we saved 85 million miles? We saw an additional 100 million miles a year when we moved to optimization. That's 10 million gallons of fuel, additionally another 100,000 metric tons of CO2. We've reduced our cost by $300 to $400 million a year. And again, you couldn't have seen it until we put the optimizations in. So I do want to go over a couple of best practices quickly, and then I'm going to go over time by about 2 minutes because I want to do something else. You need to understand the different types of analytics, what they can do and what they can't do. Don't mix them. Don't think you're going to do an optimization when you're trying to do a prediction. Data limitations will always be there. You need a data infrastructure. You need to build analytics into the process. The drivers don't know that they're using these tools, and don't wait for a perfect system. Orion doesn't do everything we want it to do, but also, more importantly, don't forget change management, and you need to learn from others. We changed metrics. These are leading metrics. We measure people on, are they using the system right? Are they maintaining the data? Are they following a solution? And people get competitive, and by using different metrics, you can change conversations, and People care about these little awards. I got this from someone in a district who was so proud that they became the #1 user. Don't forget to network like we're doing today. I'm fond of the Institute for Operations Research and Management Science. This is the head of analytics for Boeing. He's the head of their analytics society. I urge you, it's the best $200 you'll ever spend. Most importantly of it all, build a great team, and we have a great UPS team, and hopefully you'll see some of them here. I do have about 4 minutes I'm still going to use, so hopefully you won't mind.
This was drastic for us. It changed the way we load the trucks. It changed the way we plan for the driver to deliver. It changes the way the driver delivers the route.
Orion has taken a situation that was good before and made it even better.
It'll show us our entire day from beginning to end.
It has shown me possibilities that I would have never thought were possible.
We used to get excited about a 1% gain in stops per mile. And to see some of the daily operation results now over 10% easily and even higher, it's really been incredible.
It tells you exactly how to drive to your first stop and then also how you get back to the building from your last stop. So it allows me to focus on my safety aspects, lifting and lowering properly, and then also with my customers, addressing them properly, seeing how they're doing, and just being a professional.
From my perspective, it allows me to put more work on the cars, to make sure the driver doesn't have too little work and to make sure the driver doesn't have too much work. Orion allows me to put like that right amount of work on.
It's also been impressive to use the technology for peak season.
The amount of work that UPS sees is essentially doubled. With this tablet, I'm able to pretty much pull any route that we have in a building without having any prior knowledge of said route.
Being sent myself to an area that I'm unfamiliar with and using the tablet and the technology and being successful takes just a few challenges out of the mix for us from the many challenges that we have at peak.
Let's say if I'm on the road for a 9.2-hour day, and a year ago I did 110 stops, now I can do 115, 118 in the same amount of time.
Our carbon footprint, the miles that we save, the time that we're paying a driver to deliver boxes, wear and tear on the vehicle, on the road systems, oil changes, all of the above. I mean, it impacts everything we do.
Thank you. Now, Jack and Jim said I can have just a few more minutes. I'm sorry. I know this is a forced encore, but I do want to go over a couple of things if I can. We're not done. So I want to talk about what's next. We're not done with Orion. It stops when a driver leaves the building. We're going to have Orion work all day long, helping them with every decision throughout the day. We're going to give them some navigation tools, and we're going to have Orion decide which driver should get a package and take that out of humans' mind. More importantly, and I think this falls into a smart city initiative, we want to optimize the entire network. Orion is optimizing the final mile. But how about city-to-city moves? We're going to optimize that. There's an Orion we're working on city-to-city. How about inside the property? We're working on optimizing the vehicles on property where people are. And when we do that, we call that the Global Smart Logistics Network. It's a truly optimized network, but I think we should call it Sherlock. Imagine a system or a smart city that is so smart it predicts a problem's going to exist and solves it before you even know something's wrong. It's going to look like Sherlock Holmes, and that's what a smart city or an optimized network will do. I'm proud of the press we've gotten with Orion. One of the best ones is one that said, "Forget drones, Orion is the future of delivery." But UPS didn't forget drones. And we're going to need maps, Jack. So while people are trying to figure out how to make drones work, we're trying to figure out how to work with drones. You have to have the tools and the analytics to make these successful. And final slide, and this one's for you, Jack. This is Arthur Schopenhauer. He said that truth goes through 3 stages: ridicule, violent opposition, acceptance as if self-evident. And I believe things that you're doing, these innovative ideas, go through the exact same 3 stages. You're crazy, this is never gonna work. Then when you don't stop, people fight the change, they dig their heels in, but when it's done, they accept it as if it's self-evident. And Jack, I wanna thank you for turning GIS into self-evident. I know you had to go through the steps, so thank you very much.